So now we are into the second half of the trig unit. So for today, we are going to talk about the sine law, and you'll see later on in this lesson that this is probably one of the easiest concept, if not the easiest. Anyway, so it's a dash one class, so I'll still show you the come about of the formula, and then I'll show you where you can find the formula on the formula sheet. So before that, there's several things I want to quickly talk about, which is how to read off the information from a triangle. So let's do this. This is a prior knowledge you all should have, but anyway, so let's talk about the notation here. Notation. Because surprisingly, every time when I teach this topic in 20-1, there are always some students who don't know what is going on. So notation here. So let's say we have a triangle. And just let you know that by convention, we always use capital letter to indicate the vertices. So always, right? So vertices, always capital letters, not lowercase letters. Next, for the angles, we will indicate them in this case as this. We would either say A. Let's focus on this one here. So how do we describe an angle? We would say that A, if you just see this, that means it's an angle. Or you may see this. That means angle A. Right? You may also see this. Angle BAC. The one in the middle is the angle we are looking at. So BAC. So this one here. Or you can also call this angle CAB. It's the same thing. CAB, the angle in between the two sides. Okay, and then for the length of a side, we always, or by convention in math, we always use the lowercase letter. Okay, so this is angle A, so therefore this side opposite to that, we would use lowercase a. This is angle B, the opposite side, we use lowercase b. This is angle C, the side opposite to that, we call that lowercase c. Okay, and then for this one, in plain English, you can call that triangle ABC, and in math, we can also do this. You can change the order. Don't worry about the order, like angle BAC, like triangle BAC, triangle CBA. They mean the same thing. Okay. Now let's move on to the sine law stuff. So make a 90, 60, 30 triangle ABC. Doesn't matter which side is which, but obviously this must be 90 degrees, and then 60, 30, or 60, 30, doesn't matter. So this is 60 degrees, this is 30 degrees. Okay, and again, where is A? Who cares? You can call this A, or this A, doesn't matter. Anyway, so let's call this A, let's call this B, and let's call this C. Alright, next. Divide the sine ratio of each angle by its associated side length. Well, of course, we talk about sine law today, so we are going to do just the sine. Okay, so if you look at this one here, so we are looking at this as my reference angle, so you might want to turn your head around, or turn your paper around, or turn your screen around. So we are looking at this one here as my angle. Okay, then that means it is opposite adjacent hypotenuse. So sine 60 degrees, if that's my if I'm referring my triangle to that, or look at this triangle with respect or from the perspective of 60 degrees, so sine 60 degrees is opposite. Oh, sorry, I forgot to mention that if you look at this here, this is the special case. I hope you remember from last day. So 90, 60, 30, a few seconds. If you don't remember them, quickly look at your notes from last day. I'm not going to repeat myself with all those because I do need to know the length of each side so that I can fill in the SOHCAHTOA thing. Sorry, not SOHCAHTOA, this time sine only because we are talking about sine law. Alright, so from your notes, I hope you know that in this case, if we have 90, 60, 30, the corresponding length of each side is 2 for 90 degrees, root 3 for 60 degrees, and then 1 for 30 degrees. So now I know the length of each side. So let's just plug that in. Sine is opposite over hypotenuse. So root 3 over 2. Root 3 over 2. Okay, then do this. Oops. Now let's look at angle B. So this time, let me use a different color to indicate this is the angle I'm looking at. Let's use purple. This is the one I'm looking at right now. Okay. Sorry. Wrong thing. B is this one. So 90 degrees. This is a tricky one. So I'll give you a few seconds to think about this. My angle here is now, oh, so let me just keep it consistent. Yellow as a reference one, a reference angle, sorry, the angle we are looking at, and then this purple is this one here. So if this is the angle I'm looking at, so that means I have sine 90 degrees. So this is a tricky one. We still know that sine is going to be opposite over hypotenuse. What is my opposite and what is my hypotenuse? Okay, so I hope you figured that out. So opposite the angle, sorry, the length of the side opposite to the angle, which is 2. Hypotenuse is the longer side, 1, root 3, 2. So that means we are looking at this same one. 2 over 2 gives you 1. I would suggest you to look at this again and see what's going on. So last but not the least, let's look at angle C as the angle theta for our triangle. So let's use green here. If I'm looking at this as my angle, then that means my opposite is here. Opposite adjacent hypotenuse. Alright, so in this case, angle C is 30 degrees. So sine 30 degrees. Again, opposite over hypotenuse. Opposite is 1. Hypotenuse is 2. So 1 over 2. When you look at this, no big deal. The numbers are different because the angles are different. But this is not the end of the story. So now let's divide the sine ratio of each angle by its associated side length. So if you look at this is the sine ratio for angle A. So it is root 3 over 2. So if you take root 3 over 2, divided by the associated side length, which is the length for that. So big A, the length across that. So this is the small a, root 3. So divided by root 3. That gives you root 3 over 2 times 1 over root 3. To convert divide into times, you flip the foreign term upside down. So if you look at this, root 3 on top, root 3 on the bottom, so that gives you 1 over 2 for this one. Okay, now let's do this one. Divide this, the ratio, the sine ratio, by the associated side length. So this is angle B. The length of this associated side, or the length of the side opposite to that, in this case is 2. So 1 divided by 2, that gives you 1/2. Now I hope you can see something, but let's finish this and come back. So for angle C, the sine ratio is 1/2. Okay, divided by the associated side length. So angle C is here. The length of the side opposite to this is 1. So 1/2 divided by 1 is the same as, well, basically 1/2 times, flip this upside down, so that means 1 over 1. That still gives you 1/2. Now if you look at this, hopefully you don't think that this is coincident. That is more than that. Now next thing, what do you notice? They are all the same. They are all the same. So what does that mean? If you take the ratio, sine ratio of an angle, divided by its own length, then they are all the same. In this case, 1/2, you don't have to memorize 1/2. So if you look at this, sine of angle A, sine of angle A divided by the length of the corresponding side, or the side across from the angle, in this case the small a, that will give you the same value as sine of another angle, in this case angle B, divided by its associated side length. Same thing here, angle C. If you take the sine of that, divided by the length of the side opposite to that, they're all the same. So if you look at this, we have the sine law. So right here on the formula sheet, oops, this is annoying. Every time I did this, it's the same thing. Okay. So check. All right. So now it's right here. So you don't have to memorize anything. Now some of you will say, Chang, wait a second. This is not quite the same as what you just derived. You know what? If you, depending on what you're trying to find, if you are trying to find an angle, leave all the sine stuff, the angle stuff on the top. Okay? If you are trying to find the length of a side, then flip everything upside down, you get this. In this case, if you just leave it in this form, you plug the numbers in, you can find the length of a side directly. If you leave it in this form and then plug the numbers in, you can find the angle directly. Okay, so you'll see how it works in a second. So this is sine law. So here's the sine law. It's already on the formula sheet. Okay, so right, so capital capital A, small a, big B, small b, uppercase C, small c. All right. So if you might be wondering, we know SOHCAHTOA. Why do we want to use another trig law? Well, to use the sine law, you must have a known pair of an angle and its opposite side. Okay. So you must have matching pair. What's the nice thing about sine law? As I mentioned on the previous slide, you will find that it is one of the easiest concepts in Math 20-1. This is the nice thing about the sine law. The sine law can be used to find angles or lengths in any type of triangle, not just right angle triangle. So to use SOHCAHTOA, it must be a right angle triangle like this. If it is not a right angle triangle, as you all know, you cannot apply SOHCAHTOA. You can still apply SOHCAHTOA, but obviously the answer would be wrong. Here, the nice thing about sine law is you can use it for any triangle. It doesn't have to be right triangle. And if it is right triangle, of course, you can still use sine law, because as long as it is triangle, you can use sine law. But if I were you, SOHCAHTOA would be easier for a right angle triangle. Now have a look at this example here. Solve for p to the nearest tenth of degree. So if you look at this, we don't have A, B, and C. Instead, we have P, Q, R. You know what? If you are annoyed by the notation that the formula sheet sets A, B, and C, but you don't have any of those, never mind, make your own notation. Okay? Whatever you're trying to find, here's my suggestion. You call that A. Alright? So you don't have to do it that way. Right? So in this case, solve for P. So that means this. We are looking for this. So if I were you, guess what? I'll just change the notation. Call that A, and then which one is B, which one is C? Who cares? So we can call this B and then C. So you can call this B and then C. If this is A, that means my lowercase a would be this one. If this is B, that means my lowercase b would be this. If this is C, that means my lowercase c would be this. So in this case, you are looking for P. That we change it to A. So to avoid confusion, let's highlight this. So that's what I'm trying to find. And in this case, we are solving for an angle. Uppercase letter, that's the angle. So therefore, for our sine law, I would leave it in, well, I'll flip this upside down, or the form that I just showed you on the previous slide. So sine A over A equals to sine B over B equals to sine C over C. Alright, so now if you look at this, we don't know this. That's what we're trying to find. Sine A, what's the length of A, which is opposite to that, 6.2 equals, we do not do anything with C because we don't know the length of C here. We don't know angle C, so we can just deal with B here. So what is angle B? 115 degrees. So sine 115 degrees over B, the length across from that or opposite to that. So 10.8. Alright, so now what we need to do is to solve for sine A. So multiply both sides by 6.2 times 6.2 times 6.2, top and bottom, they cancel out. So sine A is, if you punch that in, so sine 115. Before that, let's double check. My calculator is in degree mode, so it's all good. Okay, so let's do this again. Sine 115 times 6.2 divided by, oops, you better do this way. Okay, so sine 115 times 6.2, oops, sorry, sine 115 close bracket, and then times 6.2 divided by 10.8. You can try to put everything together. In the past, I students who screw up that, so that's why I did each one separately. So enter that, so that gives you 0.52028. So 0.520287. Alright, then of course we do the inverse. So in this case, inverse of the number we just found, 0.520288. So let's do this. Inverse sine 0.520288. You don't have to punch in the whole thing, okay? But please do not just round it up here. Put the, like if you try to do inverse sine of 0.5, your answer will be off quite a bit, okay? Something like that. So that gives you 30.19 degrees. I know you say, Chang, you just screwed up here. Yes, I did. I know. So, sorry. Shift. Oh, second sine. Oh mine. 0.520288. Okay, that gives you 31.4 degrees, because you need to round your answer to the nearest tenth. Okay, so that gives you 31.4 degrees. Isn't this easy? Okay, next question. So if you have a look, solve for m to the nearest hundredth. Okay, so this is my big M. That means my small m is here. That's what I'm trying to find. Alright, so if you want, because you may get confused, where are my A, B, and C? You know what? You can just change the notation. You can call this A, and you can, let's put the A here, then this would be your A if you want, and then which side you copy doesn't matter. You can call this B, and then this is a small b, this is a C, big C, this is a small c. Okay, so now let's, well, since this is not a right angle triangle, so don't do SOHCAHTOA. So if you look at this, since we are trying to find the length, so therefore we would use this version. Put the lowercase letter on top, and then the angles, the uppercase letter on the bottom. So A over sine A equals to B over sine B equals to C over sine C. Okay, so let's just plug everything in and then solve for whatever we're trying to find. What's my small a? Well, let's call this A for now. And then my sine A, well, we don't know the angle, but we know one thing for sure. The sum of all these angles add up to 180. So we can just quickly punch that into your calculator. So 180 minus 37 minus 71. So what does that mean? We have 72 degrees. So this means it is 72 degrees here. So that's my angle A, sine 72 degrees. And then my angle B, if you call that C, then it will be your angle C. So B is 15, and then sine B is 71 degrees. So now manipulate this, multiply both sides by sine 72 degrees, sine 72 degrees, top and bottom, they cancel out. So that means A is 15 times sine 72 divided by sine 71. Okay, let's do this. 15 times, make sure you guys use bracket, sine 72 close bracket divided by sine 71 close bracket, enter. That gives you 15.087 blah blah blah, and we want to round to the nearest hundredths, so we keep 2 digits after decimal point. So my answer is 15.09. Okay, so 15.09, 15.09, don't forget the unit, feet. And you better answer the question. There's no such thing as A in the original part of the question, so you might want to change that to M. So that means my M here is 15.09 feet, like that. Okay, so last question here. You might want to pause for a few seconds and then have a look. For those of you who are skilled or even aiming for exemplary, you definitely should do this, or should be able to do this by yourself. All right, so if you look at this, we are trying to find the height, which is this, to the nearest tenth. So if we either know this side here, or this side here, then we can use SOHCAHTOA to find this, but unfortunately we don't. So that means somehow we need to figure out either the length of this side or the length of this side. Even though obviously we will be using the sine law, but then the thing is we still need to fill in some missing information first before we can apply the sine law. So if you look at this, let's look at this right angle triangle first. If this is, oh sorry, perhaps looking at this smaller triangle, right angle triangle would be easier. So if this is 90, this is 45, then that means this must be 45. So this is 45 degrees. Okay, then let's look at the larger right angle triangle, this one here. So if this is 90, this is 30, so that means this, the whole thing, must be 60 degrees. So knowing that this is 45, that means this smaller angle is 15 degrees. If you want, you can find out this angle here, but we really don't need this at all. So anyway, so now we know this angle and the side opposite to that. So this one, great. We know this angle, but we don't know the side opposite to this. Well, what about this one? We really don't care because it doesn't help us at all. So use this to find this. Once we have this, then we have the hypotenuse of this smaller triangle, and then we can find the edge after. So alright, so this is what we're coming after. At least we should give it a name. You can call it whatever you want. You can call it A, you can call it X, or whatever. So here I'm going to call this X for this one. So now if you look at this, we are trying to find the length of a side. So by looking at the sine law, we want to keep it this way. The length of the side on the top and then the angle on the bottom. So I'll just write down A over sine A equals to B over sine B. If you want, you can label whichever side you want, A, B, C, things like that, but here I'll just plug the numbers in. So the side we are looking for would be this. So this angle, corresponding side, this angle, the corresponding side. So our unknown is, let's call that A here if you want. Okay, so A, and then the angle opposite to this is, or the matching angle, if you want to call it that way, is 30 degrees. So sine 30 degrees equals the length of the other side given to you. So this one here, 10 meters. Let's just write down 10. We can put the unit in after. And then the angle opposite to that is 15 degrees. So sine 15 degrees. Alright, so some simple manipulation. Multiply both sides by sine 30 degrees. Sine 30 degrees. On the top, on the bottom, cancel out. So now just plug these numbers into your calculator and find out their value. Alright, so 10 times sine 30 divided by, oops, let's do this again. 10 times sine 30 divided by sine 15, close bracket, enter. So for this number, it's not the final answer yet, so don't round it off. For those of you who have experience in Chem 20, Chem 30, you know what I mean. And if you have no clue, never mind, just don't write down 19. So keep a few extra digits, so 19.3185. 19.3185. So this should be good enough. Now we know this. If you want, you can write down x is equal to 19.3185. So now you know this side, and you're trying to find this side, and this is a right angle triangle, and the angle we are looking at is 45 degrees here. So that means this is opposite. This is the hypotenuse. So that means we should be using sine. So now we are looking at this triangle. So sine 45 degrees equals to opposite, which is the height here, over the hypotenuse, the one that we just figured out using the sine law, which is 19.3185. I'm not going to show you how to plug this into your calculator. So cross multiply sine 45 times 19.8135. Okay, so after rounding, for the rounding, you want it to be the nearest 10, so keep one digit after decimal point. So after that, with the correct rounding, you should get 13.7. And now you have to put the unit back. The unit here for the length is meters. So 13.7 meters. Okay, so that wraps up this lesson here.